So just some reminders before we get into the video. First reminder is to make sure that you're keeping an eye out and an ear out for the key word for this lesson. Reminder number 2 is to make sure you're taking notes. Include the date, lesson number, aim, and standards to help you refer back in your notes. Let's get to it. So continuing from our lesson number 5, here is questions 4 and 5. So for number 4 and 5, you're going to do on your own, but before you do that, you need some important information. For number 4, for 52 cell phones for Verizon. And then for number 5, you're going to need to know the 7.25 inches for a rectangular room. Pause the video here. Try these 2 on your own, and then we'll come back and check the answers. Okay, so number 4, 108 students were surveyed about their cell phone provider. The results are shown below. If the total population was 460 students, what is the best approximation for the total number of students with Verizon? So we're focusing on Verizon. We're told that 108 students in total were asked, and we're predicting for 460. So we have our totals, we just need the part. So 52 out of this 108 are Verizon. We need to figure out how many students have cell phones with Verizon out of the 468 total population of students. So here we're going to cross multiply again. 52 times 460. So we have 108x equals 52 times 460. We have 108x equals 23,920. And then we're going to divide both sides by 108. X is going to give me 221.481 and change. I'm going to look to my nearest decimal because we're talking about students, so we can't have decimals. And it's going to be 221 students out of the 460 have Verizon. And that is our answer for number 4. For number 5, so we are given the dimensions of a scale drawing, 2.5 inches by 7.25 inches. We want to know what the actual area is of the family room when the scale is 2/5 of an inch to 1 foot. Now, here is something that's very interesting with number 5. We're given 2 sets of dimensions, and then we're given a scale factor. Knowing the scale factor and the proportion and how we set everything up, this is too much information to set up in a proportion. That means you have to do 2 separate proportions for each dimension. So the key thing about area is you need to first find the dimensions scaled up or scaled down, and then calculate area or calculate perimeter. You can't find the area and then calculate the scaled up area. It won't work. So for number 1, well, let's use your 2.5. This is our inches. And we are trying to find the number of feet in actual area with this new scale. So we have 2/5 of an inch to 1 foot. We're going to cross multiply. So 2/5 x equals 2.5 times 1, which is just 2.5. We're going to divide by 2/5. I am going to get x equals 6.25 feet. Then for the next dimension, I'm going to set that up with 7.25 inches over x amount of feet. Using the same scale factor, we're going to cross multiply. We'll get 2/5 x equals 7.25. You'll divide both sides by 2/5. and you're going to get x equals 18.125 feet. Now this is just finding the dimensions. Now we actually have to combine them in an area. So I'm just going to take this, I'm going to shrink this and put it right here. So I'm going to take these two dimensions and I'm going to calculate the area. So I have area equals 6.25 times 18.125. Use my calculator, I am going to get 113 and 932 feet squared. So when you're dealing with area, you're dealing with units squared. I converted mine to a fraction because it was a long decimal. It's 9/32 feet squared. And I had my 113. And that would be my answer for number 5. So this was a lot of information. We covered 2 different concepts in a real world situation. We have sample population, something like number 4, and then we have scale factor, something like number 5. 5 is a multi-step real world example of proportional applications. If you have any questions, make sure you write them down to ask me. Make sure you're identifying your keyword, and I will see you guys in the next video. Bye.